ওয়ালাইকুম আসসালাম। তোমাদের ক্লাস ছিল নাকি?
জি স্যার, মাত্র ওই যে রুহুল আমিন স্যারের ক্লাস শেষ হইল।
আমরা আর কিছুক্ষণ ওয়েট করি, 2-3 মিনিট। আচ্ছা, 88 আসছো এখানে?
ইয়েস স্যার।
আচ্ছা, রুহুল আমিন স্যার কি আজকে কি কভার করছে? মানে কভার করছে, এই কনভলিউশন
জি স্যার।
করছে?
জি স্যার।
কনভলিউশন পড়াইছে, তাই তো?
জি স্যার।
দু একটা এক্সাম্পল দেখাইছে নাকি? এই উইকে মনে হয় আরেকটা ক্লাস আছে।
এই উইকে আরেকটা আছে, এক্সাম্পলও দেখাইছে স্যার।
এই ডিসক্রিট কনভলিউশন নাকি কন্টিনিউয়াস টাইমের?
কন্টিনিউয়াস।
কন্টিনিউয়াস এর দেখাইছে, তাই তো?
জি জি।
আরেকটা ক্লাস কবে তোমাদের?
স্যার পরশুদিন।
I think we can start.
ইয়েস স্যার।
93. 93, are you here?
ইয়েস স্যার।
So maybe after joining 20 students, rest of the 8 are like that. Okay, I'll join after 10 to 15 minutes. So I think there is no point for waiting for them.
ওকে স্যার।
Sir, will you give us permission to record?
Okay, normally we record the session with C1. So what do you think? I think one class is recorded officially, like from our side. And is there any problem? In the last 2 classes we have recorded with C1 in the afternoon session, and we have uploaded that one. What do you think? Is there any problem, or you want to
It was
record?
okay, I think. Sir, can I ask something about the last lab
Yes.
report question? Sir, there was a question in the report part. What is the physical address of the content 07H in memory? There was a table after that. This was the question.
Yes.
So in the table, it was given that move BH, 07H. So we are moving the 07H to the BH register, right?
Yes.
So if
Yes.
we
Yes.
are
Yes.
if we are doing it, then it is going to the register, not in the memory. But
Yes.
the
Yes.
but
Yes.
but the question was, what is the physical address of the content 07H in memory? So what will be the answer of this question? Because it's not going in the memory.
So what's the question number? What was the question number? Okay, I got your question, but basically you can see there is IP. So IP is also have 07H. I think that is the last question. Last question, I hope. So if you are asking about the last question, then you can see the IP has also has a address of 07H. Okay, let me start today's class.
It was the question number B, not the last question.
No, I am asking that is related to the last portion of the question. Yes, isn't it? That is meaning the second page. The question was in second page.
Yes, sir.
Yes, that's what I am saying. That you can see there. Okay, we can discuss this later. So just to give you an idea, you can see there is IP, and IP has is also is having 07H. You can see there is 0006H and 007H. So and what is the physical address of content 07H? It doesn't mean that after which
Can you
command.
share your screen? It will be better, sir.
Okay, I think you are talking about this one, isn't it? Can
Yes,
you
sir.
see?
Yes, sir.
Yes. So you can see here there is physical address 006008. That means there is something in between, that is 007. So he was asking what will be the thing in that 0007H memory. It is not about this moving. You got my point?
But sir, it is asked that the physical address of the content 07H in memory. So it was a bit
Yes, physical. If
confusional
you yes, what is the physical address?
of the content 07H in memory. But, like it was
It should be
confused.
okay. What is the physical address of 07H content? Basically, you do not need to bother about the content.
কোশ্চেনটা তো ঠিকই আছে, দেখি তার ওর কোশ্চেনটা কি, তোমার কোশ্চেনটা কি বলো তো?
ওর কোশ্চেন হচ্ছে যে এখানে কন্টেন্ট লেখাটা তো কেমন, মানে 07H যদি থাকে তাহলে ও ডিরেক্টলি এফ আর 07H দিয়ে
তাই
সে
তোমার কোশ্চেন
ফিজিক্যাল
কি
অ্যাড্রেস।
এটা যে কন্টেন্ট কেন? ইজ দ্যাট ইওর কোশ্চেন?
আমার কোশ্চেন ছিল স্যার যে 07H বলছে, আমি ভাবছি যে এখানে যে থার্ড লাইনে যে মুভ BH 07H এই 07H টার কথা বলছে।
না 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 না, ওইটা না, ওইটা না। তুমি কোশ্চেনটা বোঝার চেষ্টা করো, ঠিক আছে? তোমাকে জিজ্ঞেস করছে হোয়াট ইজ দ্য ফিজিক্যাল অ্যাড্রেস অফ দ্য কন্টেন্ট 07H ইন মেমোরি। সো এই 07H বেসিক্যালি তোমার ওই আইপির অ্যাড্রেসটা ইন্ডিকেট করতেছে। সো ওইখানে তোমার কন্টেন্ট কি আছে দ্যাট ইজ টোটালি, মানে তোমার জানারই দরকার নেই কন্টেন্ট আমার কি আছে, তোমাকে জাস্ট জিজ্ঞেস করছে ফিজিক্যাল অ্যাড্রেস কি। সো হোয়াট এভার বি দ্য কন্টেন্ট, তুমি জাস্ট ফিজিক্যাল অ্যাড্রেসটা জানাবা।
ওকে স্যার।
ক্লিয়ার কি রবিউল, ঠিক আছে না?
হ্যাঁ হ্যাঁ আচ্ছা, I think we can move to our today's class, and if you have even if you have any confusion we can discuss that at the end of the class. Huh?
So you could give us the permission to record.
Listen, regarding recording, we record our every second class or every second lab of the week. So yours is the first lab. So which is the section who is having second lab, Robiul?
C1.
C1. So we always record that one, and that is shared with all of you. So is that fine?
Yes, sir.
Okay. So you always get the recorded version, I think.
Okay, today's lab is basically with introduction to, we'll see today. Okay. So it is just an introduction to assembly language. How and it is the first lab you will be doing the program, and you will see that we will do 2 or 3 programs. But before writing a program, you know that every programming language. Am I clear to you? Am I audible to you?
Yes,
Yes,
sir.
Okay. So what I'm saying that in every programming language, you can see there are some rules, there are some regulations. Okay, we need to follow this one, otherwise there will be error. So you know that the assembler, in case of assembly language, the assembler translate the assembly code into machine code. So the assembler has some rules. Okay, I can do this thing, I cannot do that thing. So basically today's lab is basically most of the things are knowledge based, and finally we will try to incorporate those knowledge in case of our writing the program. So these are the content of chapter 4. Basically it is chapter 4 of Marut. So you can find the you can just go through chapter 4, and these slides are made for our convenience, that we can deliver the things in an easier way to you, and it will be understandable to you. But basic thing is that you can go through the book, and that is the basic idea, that go through the book, but for delivering the things, it is needed that we want to have these slides. So we'll go serially, but at the middle, maybe this one, this translation from higher level, and also creating program and running, maybe this will be discussed at the last. But we'll come serially, and you can see, if we see just the contents, that we'll first of all see what are the instruction, and how to write each line of the code, and how what are the regulations in case of data, in case of variables that we have. Then we'll see few basic operations, related to assembly language, and also sorry for the interruption. So after that, we'll see the program structure, and how should the structure be whenever we'll try to write a program, the structures. And then we'll see how to take input, how to give output to the monitor, and then we'll go to the first program. So let's see what happens. But actually, at the end, you will see this is one of the programs that we will be showing today. So here is the program, and basically we'll take one input from the keyboard, and we'll show the output. That will be our first program, and maybe second or third program will enter a letter in lowercase, and that will be translated in in uppercase. So that is I should say these two, but like, we can take input, we can give output, and also we can give output of a string. So single key input we can take, single key output we can give, and also a string, if you want to show a string or a letter, then you can show that one. So that is the thing. So before moving to the main part, I will ask one of you to assist me, so I can have an idea that you are getting the points.
Yes, sir.
Okay. Let me ask 109. Are you here? 109.
Yes, sir.
Okay. I hope that you can be with me, isn't it? Okay. So the first thing in the assembly language syntax. So at all these what should I say? All these topics, I am just pointing out to the things that are related to this topic. So what about the comments, and what are these things? We'll try to see. So let's go to the next one. So in assembly language, what I was saying, that you have an assembler. So that assembler translate your language, your assembly language, into machine code. So this program that you're writing, that is obviously consists of statements. You can see they are statements, and these statements are divided into either these are either instructions or assembler directive. So the assembler translate the instructions into machine code, and assembler directive instruct the assembler to perform some specific task. So are you getting me?
Sir,
109.
sir, what's the assembler directive? Can you explain again?
Yes. I will explain in detail. I will go to each by each. First, try to get that here we have two things. That one line is start, then move cx, 5. Then we have a comment here. So basically, each of the statement have this. There can be this number of what should I say? This number of classification. There should be a name. There can be a name. There should be an operation. There will be operands, and there can be comments. So I'm just coming. The first line that you are seeing, this is an example of an instruction. And the second line is a example of your assembler directive. Is it okay? So main program, whenever you will see that there is you will see that thing. This is the main procedure. We normally call it main procedure. If you see here, so this main program, main procedure from here to the end. So it will instruct the assembler that the procedure has been started with the name main. That is the thing with your assembler directive. But whenever you write move cx comma 5, so that will be translated to machine code, and you have seen that one in the last groups, that the start, we have not seen the name part, but we have seen move cx comma 5 or something like that. Basically that can be translated into machine code. That's what I'm saying, that there each statement of a program is, it can be either a instruction or assembler directive. Is it clear now? Is it clear?
Yes, sir.
I cannot hear you.
Yes, sir. It is clear.
Yes, sir.
Yes, sir.
Okay. So let's come to the points, the name part, then the operation, and also the operation commands. Let us discuss few of them. Sorry. So basically the name field, we have some rules here. So the name are used for instruction labels. Sorry. So the names are used for the instruction labels. Like whenever you see in C programming that if you want to jump to somewhere, you need to give a name there, then you can jump there. If I'm not wrong. So that is the basic thing. Whenever you have a
So I did not understand the jumping part. What did you say?
no, I'm saying then whenever you want, if I, it is not working. Okay, wait. I'm there's a problem with my. What I was saying is that you need a label, like in case of C programming, if I can remember few of the things of C programming, or in any other programming, whenever we want to jump to some location, that want to jump there, so there can be a label, like you can give a name there, okay, so that we can jump there. How did we jump in case of C program? If we do not go to C program, no problem. Just whenever you are writing a code, like if I go to the previous code, so if you want to jump to somewhere, or if you want to give a name or a start point of somewhere, then you can just add a So is it clear that what the label means? That is just a giving a name to the start of any instruction. That's it. It can be, so the names basically can be of any instruction, or can be of the procedure, or it can be of variable name. So we'll see. So there are some rules, and basically whenever we write a name, the assembler translate that name into a memory address. So all the names, so this, if you give a name, is start here. So basically the assembler translate that name into a memory address, so that whenever you call that name or you want to jump to there, so in that case they can jump to that particular memory address. That's it. So there are different, there are some what should I say, knowledge-based thing. That is, the names can be from 1 to 31 character long. Those should be letter, digit, and special characters. Only these are permitted, and no blanks. Blanks are not allowed. Digit cannot be first character. Period must be at the first character, and there is no difference between upper and lower case. This is not case sensitive. Is it clear? So just few knowledge based things. So here we have some examples. So 109, can you tell me 2 words here? Is it legal or illegal?
Illegal.
Illegal. Okay, then dot test.
It is legal, sir.
Okay. So these are the things. So here one important thing is that if you just want to run anything from here, let's say you give something illegal, that means a dot cannot be at the middle. So if you run here, so okay, so basically this program will show you an error. So if you just correct that one, this program will run. So whenever you write something error in emulator, that will not be executable. Is it clear? So
রবিউল আগেটা যা,
we'll
আগে ইয়েতে যা, ওই ইয়েতে একটু যা, এমুলেটরে যা।
আচ্ছা যাচ্ছি।
Do the same mistake, give ms.g. Okay, so can anyone answer over here? So we made an error in line number 8, but we are seeing the error in line number 17. Is there anyone who can explain why?
Sir, MSG sir মানে define করি নাই sir, ms dot g
Exactly. That is what the error was created in line number 8, but when you are using in line number 17, that is where you are getting the error. Okay,
so it is also basically you're defining something that which is not allowed actually, so that
So
can
sir,
be
if we don't use that ms.g, it don't show any error.
no, it will not show
yes,
you
yes,
any.
yes.
If
It
you
will
do
not
not
show
use,
any error and it will run.
yeah, if you do not use msg anywhere in the code, it will not show you any error.
Yeah, you can see, you can run the program, that is your output. Okay, so okay, it is very good practice that you use comment field, because the assembly language, you can see there is very that is not like our usual programming language. So it is obviously better, otherwise you will lose your thing. Okay, why I have written this thing? So after writing a 100-line code, you cannot find the thing. So okay, where did I write and why I have written that thing? So for that reason, you can write the code comment, but thing is that the comment should not be like that. Okay, I have moved 0 to cx or 5 to cx. It should not be like this, but you can write the cx counts the terms and initialize to 0. So I have it should be 0 actually. So that is the thing, you need to write the comment so that you can understand, not the way that what you are doing. So what are you doing, that should be in real language, not in the coding. Like you're moving something to cx, that is a silly comment. Obviously you can write, and to write the comment, this is the semicolon. After semicolon, whatever you will be writing, so that will be as a comment, that will not be part of the program. Is it clear?
Yes, sir.
Okay, so then if I go to next field, that is the operand. We have discussed about the name and comment. Then we are going to the operation. So I have said basically the statement can be of a instruction or an assembler directive. So here the operation terms, in the operation term we have move, add, sub, maybe we have seen some of those things. These are this operation field contains a symbolic operation called operation code, and these translate the symbolic operation code into machine code. The assembler basically translate the symbolic, so these are called the opcode. These are called opcode. So the assembler basically translate those symbolic opcodes into machine code. And in case of assembler directive, you have something, the procedure, or there are other assembler directive. We will see those things. And in case of this thing, this is actually for creating a procedure, and you will see that that is not translated into machine code. Try to remember, the directive is not translated into machine code, but it gives the directive, it gives a direction to the assembler that do this thing. Like here it is create a procedure in the code segment. So that will create a procedure there. They are simply tell the assembler to do something. That is the thing. So these are called CUT operation code, or you can say, you can call CUT op. CUT op. Sometimes we give the short name, something like that.
Yes, sir.
So that is the thing, and then we have operand field. So basically, you will by this time you will know that only this portion is left. So operand field is something like that on which you will act upon, or you will act on, like the instruction you have move. So what to move where? So that is the question. So that will be answered by your operand field basically. And then you will see there can be different destination things, and destination operand and source operand, and you have already known from the move and add all those. Then we have destination and source operand. So there can be different operands. So no operand is possible also. No, that means there is no operation, but there will be a loss of cycle. So if you want to make a delay of 1 second, then you run that no a number of times, that will create some delay. And if you calculate the exact thing, then you will get exact delay of 1 second. And maybe you will see those things in case of my controller that we'll be doing in the next semester. So then after that, increase AX, there is one operand, so it will only increase that AX by 1, or decrease that, there is one operand operation. Then again, add, for add we have 2 operands. So that's the thing, just giving an idea what is operand. So now by this time we have come to know about the name, operand, operations, and command. So these are the different parts of the instruction and assembler directive. Is it clear?
Yes, sir.
What? Huh? Okay. Oh, no, 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 no. Okay. What was that? That is a register. What is that name? Operand register. That is a register. We're not talking about register. We're just classifying different parts of a statement that can be an instruction or an assembler directive. Here we're saying that whatever the operation that we are doing, so we need to act upon something. So those are named as operand on which we will act upon. Have you got my point? Okay. So that is a register, that is a different thing, and that is not related to this one. Okay, now we'll see the program data. So there are some rules in case of the character and numbers. So let's see. So basically, the processor I have we know by this time that those are binary data. So whatever we're writing in, we can write the assembly language, that the variables or the constant numbers, those can be of a binary, or it can be decimal, or it can be hex. But the assembler will translate all those things into basically the binary. So in assembly language, we can use binary, decimal, hexa numbers, and also the characters. So all these things will be translated to binary. So how can we actually denote that whether a number is a binary or that's a decimal or something, some other thing is there? So here, this is the thing, and I have said that there will be they are not case sensitive. So even you can write B in uppercase or D uppercase, H in uppercase, those are the same thing. So whenever you are writing a number and after that you have written B, so that will be a binary, that will be considered as binary. If you write D, that will be considered as a decimal. If you write H, that will be decimal. And again, one thing is that it is an important thing. Every hex number must start or begin with a decimal digit. So if you want to write, like say FFFF, so you cannot write FFFFH. You need to start with a with something that is decimal. So even if you want that this will be stored in AX or BX or anything, or you want to move this, or you want to act on this, so even after that you need to give a 0 there. So because all the hex numbers should start with a 0. So if you do not write anything after the number, then the assembler will consider that one as a decimal. Is it okay? So here you can see the first one. Anyone was asking?
Sir, automatically decimal.
Yes, yes. If you do not write anything, that will be considered as a decimal. So here, even if it is looking like that, okay, it can be a binary, but we have not written anything. So basically, this is a decimal number. But if we write B there, so that will be binary. So again, writing D will be decimal and illegal because we have a comma here. And also you can see this is a hex number. So can anyone tell me why these two are illegal? 48. 48, are you there? That's the Asif Rahman.
Yes, sir.
Okay, can you tell me why these two are illegal?
Sir, it's because of the wrong indication of the hex number, sir.
Of this wrong indication of hex number. I want a specific answer. Anyone else?
Yes, sir.
Yes, sir.
Okay, 34, 34.
Sir,
34. Okay, 034, 034. Yes.
so in the first case, we see that it's given as 1 before D, but since we know that in case of hexadecimals, we need to add an H at the last of the digit. So
Yes.
in this case, it's not present there, so it's illegal. And the next one, if H, we know that the beginning of an hex number should start with a decimal value.
This is
So
0.
we want
Okay,
to
another
consider
thing is that
the
you can see
decimal.
you have written D, 34. You have written D here. So it can be considered as decimal, but you can see there is a B here. So B cannot be a decimal number.
Yes,
So
sir,
basically it will expect to be H there. Is it okay?
yes,
Yes, sir.
Okay, okay. And also whenever you write a character like in a single or double quotes, that can be a single quote or double quotes. So A or hello, whatever you are writing, the assembler translate that to the corresponding ASCII code. So for a capital letter A, so the corresponding ASCII value is 41H. We're talking about hex number. So we'll see a list, obviously in emulator. Then you can find that different character has different ASCII code. And last class I have asked about the ASCII code, and you have said that okay, sir, we know that part, that what is an ASCII code, isn't it?
Yes, sir.
Okay. So then let us see about, okay, what we have learned about the number, how to define a number or character, and how the assembler deal with numbers and characters. Now basically see the variable. So here in case of variable, you have you can have an array, you can have a character, or whatever you have. Let us see what are the things that we can have in case of assembly language. So when an integer variable is declared, the assembler allocate. Whenever you will declare a variable, the assembler will allocate memory space for that particular variable. That is very important thing. And the variable name becomes a reference to the memory space allocated to that variable. That means you can whenever you are using that variable, that actually indicates the memory space that has been allocated for him. So if you want to say what is the content inside that variable, that basically says what is the content of the memory space that has been allocated for that particular thing. So basically, assembler allocates memory space for the variable. So how much space should be allocated for a particular variable? That is defined by, okay, there is sudo op. I have said that what is sudo op? So that is basically directive. So this db that is defined a byte, that is giving the directive to okay, we will have a example here in the next page, and I'll go back there also. So whenever you're writing byte 1 db5, this db is giving a directive to the assembler that assign 5 to a particular memory location. So that has been given to byte 1 variable. Have you got my point? So db is basically a sudo op. That is just a directive. Okay, now you have defined byte, means So it will basically give you 1 byte of memory address, and then you can, for a data word, uh, the defined word. So if you, that for that particular variable, 2 bytes of data will be allocated. Basically in our programming, basically we use these two basically, and other define double word, define quad word, and define 10 bytes, those are other things. Maybe we will note those, we do not need those things, but for your knowledge, you can also define a variable using dd, dq, and dt. So here the thing is that you need to define the name of the variable, and initial value should be there, and also this middle thing is a pseudo op that will give the directive. So here you can see two things. One is byte 1, then db5. Basically that will assign byte 1 will be equal to 5. That is the thing. And other thing is that what will be the byte 2 case. So it will be one byte will be allocated for this variable, but that is uninitialized. Sometimes in C programming, if we say we just write int a, b, c, then you keep those things for the use of for later use. So that is basically, you can just compare these two things, that you are just uninitialized with any value, but you can assign a value later on to this variable. Is it clear?
Yes, sir.
Okay. So those are the byte variables, and these are the word variables. So in case of word variables, a total number of 2 bytes will be allocated for each word, and also you can see there is uninitialized word. Okay, so here is one thing, and maybe one of the section, one of the students from one section, I do not know which section, but he has asked about how this will be saved, because in a word basically we'll have a memory location. Let us say we'll see that thing in the next, how the memory location. Let us say a word of 00300 So these are the memory locations. So how this will be saved? So in the lower byte of the word 3 contains 34. There is the lower byte, it will contain 34H, and the higher byte will contain 12H. Is it?
Yes, sir.
So yes. So because in the memory location, each of the address can have only 1 byte. So if you are defining a word, there should be two memory. Two memory addresses should be allocated for that particular word. So what I'm saying, that you need to how that 12 and 34 will be assigned. This is the case for 12 and 33. That means the lower byte of the number will be going to the lower byte of the word, and the higher byte will go to the higher byte. So that's it
Sir,
for
the
word
data type
variable.
GW.
Yes.
Sir, the data type DW. Can you go to the previous slide a bit?
Yes.
Yeah. So, sir, there is defined word that it means that there will be two consecutive memory byte that will be allocated to that variable.
Yes.
Not a character. Not a is it a character or integer? It's not defined here. Is it
No.
like this?
It is not. The two. So basically, define whatever we'll have that can be a character, and obviously that character has an ASCII code. If you have an integer or
Yes,
if you
sir.
have a decimal number, those will be transferred to binary, isn't it? So if you come here,
Yes,
so
sir.
you can see that -2 will be converted to a 16-bit number of binary. That will be saved in word
So
1.
wait, Rubil, let me answer
Yes.
this one. I think he's getting a bit confused with this C programming concept. Whenever we declared a variable in C, we defined whether that will be a character or integer, something like that. But in assembly language, we do not bother what will be the contents inside a character. Sorry, content inside a memory location. We are only interested in assigning the size for that particular variable. Okay, don't get confused with this C.
Okay.
Is it here now?
Yes, sir. It's clear now.
Okay. So that will show an error. You got my point? Okay, that will show an error means I will show that part. So if you have, just in this case, you have a byte 1. So you are, let us say, you know that AX is a 16-bit register, isn't it? So if you write move AX comma byte, so that will also give you an error. Have you got my point? Because if I have defined that one, but in case of declaring that in the variable, you have a flexibility that I'm showing you here. So an array, okay, then you are going to array variables. So the array is a sequence of collection of variables, and those are the same type and size, and the elements occupy the consecutive memory locations, and also the program reference to each element related. Basically, the program start reference to the start of the array. So whenever you want to, okay, I'm just giving the example. So let's see what happens. So those are just written thing. I'm just explaining in my own way. So you have defined two things here. One is B array and one is W array. So DB and DW. You have three variables here. So let us say your B, for the case of B array, your address is start from 200. So here 200 will be assigned to the first, that is the B array. It will be assigned to B array, and the address is 200, and the content will be first content. That is of 1 byte. So then in the 201, there will be another one, 202, the consecutive one. Think that you can access this particular 220H or this particular 30H by writing B array plus 1 or B array plus 2. So B array will be pointing to the first element, B array plus 1 will be pointing to the second element, and the third element. So the same thing, but in this case, the memory location will be shifted by 2. Here we have 301, and here 303, 305. That is the thing. You have total 6 memory location. In the first two, 301, 301, you will have the first, and also W array will be pointing to that first one, and then W array plus 2. In this case, you can see we are shifting, we are increasing by, we're increasing the symbol by 2. That means you are going to 302. So these are saved accordingly. Is it clear? Is it
Sir,
clear?
if sir, as we are defining one memory location at a time, just the B array thing, and after that we are
Yes.
just taking plus one plus two for the consecutive parts. So
Yes.
if there is another variable that is referring to the like here B array is 200H. So if there is another variable that was referring to 202H or like that, if we are accessing that variable by
Okay, maybe I have got your question. So you are saying that if something is, so whenever you are declaring a variable, whenever you see the program, you will see that we declare a variable in dot data, in dot data program structure. So here all the variables are declared. So whenever we are declaring a particular variable, that can be an array or that can be a single one, that can, so we are not controlling the memory address. That is the thing we need to know. We're not controlling the address. So when it can be an array, it can be a character, it can be a defined byte. Whenever you're writing the code, and after that you have given this to assembler, so the assembler will assign the particular memory location to this particular one. So there is no chance to overlap. Have you got my point?
yes,
Are
sir.
you getting? Yes.
So, sir,
So
another question. So, the
yes.
assembler translate the code at the whole code at a time or line by line at a time?
Okay.
Like, sir, for compiler, we know the it translates the whole code one at a time, but for the interpreter, it just translates one line of the code at a time. So, what kind of translation it does? The assembler.
Oh, okay, I cannot give a precise answer here, but whenever the whole thing will be, whenever the whole thing will be executable, then you can execute. You cannot execute line by line. Whenever you are compiling, whenever the assembly will make that executable, then you can run those things line by line. But thing is that it actually compile the whole thing. After that, it makes it executable, and after that, you can run line by line. Have you got my point? Is it clear to my?
My question was when translating into machine code.
Yes. I have said that
When
I
translating into
cannot
machine
answer
code.
this precisely, but we can search for that one. But what the assembler do, it makes, okay, there are some steps how the things are going on. So maybe in this chapter also, and we have a discussion at the end, thing is that there are some steps by which this text document, we are writing the assembly code, that actually makes .exe file. So there are 3-4 steps in between. So in each of the steps, basically things are checked, like whether the things are okay or not, the rules or not. So this is not, I think this cannot be directly related to C programming or other things in case of assembler and compiler. So maybe we can discuss at the end. There are some steps I can show you, and also those things are not worked in Windows 10 if even, but we have a small discussion on that also. But whether that is a line by line or as a whole, in that case, I cannot give precisely answer. But thing is that whole thing will be made executable. After that, the thing will be executed. Is it clear? So obviously, if you go inside that one, obviously that will be a line by line operation, whether that will be checked line by line. But as a whole, that should be made executable. So here, the same thing, you can define a character ABC that will be basically stored like this. 115. 115.
Yes, sir.
Maybe we'll discuss a bit about that one at the end. Okay.
Okay, sir.
So the letters ABC, if we just define like this, so these letters will be saved something like this, and this is the corresponding ASCII value of A, B, and C. So also you can directly write. There can be a mixture of characters and numbers that can be, you can write in the message that hello, then comma, then 0DH, 0AH, then a single character. You can write like this. And also basically in the message, you will see this is saved as H, the corresponding code of ASCII value of H, corresponding ASCII code of E, then L. So this is H, E, L, O, then this is 0H, and this is the ASCII code of $sign. So that is the thing. So what I am saying is that you can declare a variable with the string or character that is basically saved in the memory with what should I say, with the corresponding ASCII code. So inside a string, okay, there is a question. Inside a string, the assembler differentiate between the uppercase and lowercase. But in the code, like if you write move in the lowercase or move in the higher uppercase, there is no problem with that one. But this A is different from this A. Is it clear? Okay. So then there is a name constant. Okay, let me discuss about this one. So you can EQU. So these are basically knowledge thing. If you go to the next thing, then we are starting with the coding from the next slide. So basically we are in a position that we'll just see that how the things works. Okay, like this EQU, the thing is that you can give a name to a constant so that you can use that thing repetitively, and that makes easier to understand. And obviously there is the symbolic name. So let us say here type your name. You want to write this thing a number of times, so you can just write EQU and give a name to that particular particular constant, or these are nothing but ASCII values. So this prompt can be used anywhere in the code, and that will basically do a work that will actually, instead of these 2 lines, you can write this single line, and that will not take any memory. So that is the particular, I should say, advantage of using EQU. So these two, they're writing, giving the type your name, and then you're giving the prompt. So that will take memory location, but this will not take any memory. So this particular 0AH and 0DH, another thing, 0DH, you can see those are for going to the next line in the assembly code. If you want to go to the next line, then you have to go, run carriage return and line feed. So in that case, you can also use that particular EQ. Okay, that is actually you can use that elif. That is an option, I should say, and it can be used. So obviously it is a CU2 opcode. It gives the directive. Okay. So we'll see the inside the code that will what should I say, like okay, during the code, whenever the code will be run, like what should I say, that is the what should I say, that is a attribute of the assembler, I should say, that whenever it's the EQ, so basically it equates this one. That means whenever you will use this one, that will correspond to this particular one. So okay,
may I try to answer, Rubiul? Can I add something?
Yes, obviously.
This line that says that no memory is allocated, it basically signifies that your memory means your physical memory, that is your separate memory segment that is there. So in that particular memory segment, actually no memory is allocated for this type of instructions. How the microprocessor allocates these things within the microprocessor, that is up to the structure and its own process, but a separate physical memory address is never allocated for these EQ commands. Is it understood? It might happen that the microprocessor is storing it temporarily somewhere within the microprocessor. That might happen, but the physical memory will not be used for this particular type of instructions. All right.
Okay. So let's move to our basic instruction. Maybe we'll see 2, 3 of them, 5 of them. So already you know why we use move. Move is for basically transferring the data. So the basic instruction is move, then you write the destination operand, then the source operand. So if we write move AX BX, then basically we have AX, we have 08 and 06. Then if we just afterward, BX value will be moved to AX and BX value will remain same. So basically the idea is this will be moved here and the previous value will be erased, and this BX value will retain. That means that will be there. Is it clear?
Yes, sir.
Okay. So there are some legal illegal issue. You can see there is a table. We have destination operand, we have source operand here. So so we can move from source of a general register to a general register. So we can move from here to here. We can move from here to here. So also this we can move from here to here. So just I'm giving one example here. You can see word 1 and word 2. At the beginning I have said the assembler assign a particular memory location for a word. So those are basically memory locations. So you see, if the destination is a memory location, this one, and the source is memory location, there is a no. That means we cannot move this one. We cannot, this will not be allowed. Is it clear? Is it clear?
Yes, sir.
Sir, does this mean যে স্যার মানে যেখানে নো দেওয়া আছে ওখানে হচ্ছে মুভ করা যাবে না, মানে মেমরি লোকেশন
Yes, that combination will not work. That combination will not work. That is the thing. So you have a source. These are the source of you know what are the general register and segment register, ESDS, all those things. And memory locations are basically the variables, and that can be and the constant numbers are just the numbers. So obviously the destination cannot be a constant. You can see here.
Yeah, I mean, carefully just carefully observe which one is your source and which one is your destination. I mean, these are two things you might get confused very often. Like over here, you're seeing no, so you can see that this is general register and this is constant. That means if your general register is the source and if your constant is the destination, then in that particular case it is no. But look at over here at the end, if your general register is the destination and constant is the source, in that case it is allowed. So make sure you see which one is the source, which one is the which one is the destination, and then see this chart.
Okay, there is one thing. When if you want to run something wrong in the emulator, that will show you error. So if you want to move if you write word one move, then it will show an error. So you need to find out why this error is occurring. Is it clear?
সেগমেন্ট রেজিস্টার হচ্ছে যে আমাদের যে সিএস তারপরে
Yes,
ইএস
yes. CS, DS, ES, yes, yes.
আর জেনারেল রেজিস্টার হচ্ছে জেনারেল পারপোজ রেজিস্টার যে এক্স বিএক্স
AX, BX, CX, DX. Yes.
ওকে স্যার
So here we have another thing, exchange. If you want to exchange between a register or a memory location or between two registers, same thing, destination. So try to remember the first point is basically the destination, second one is source. So if you want to exchange between AH and BL, that means we are referring to AH and BL. So afterward AH and BL. So if this is the initial values, then after exchange this AL will go there and 05 will go there. So that is the thing, that those values will be exchanged. And other value that, and another thing you can see here, that we can access AH AL separately, and we have said that, and by total we can say that this AX. So we can actually access those things separately. So here we have also another we can exchange between two memory location, but all other things are okay. So those can be done. Is it okay? I hope so. It's just normal thing. Okay, then add and sub. So in case of add, the destination and the source. So in this case, what will happen? AX will be added to BX, and that will be saved to AX. That is the code. So finally the things will be stored in the destination. So here you can see we have 8 and 6. If we add these two, that will be E, and this 6 will be here. So the source are not changing. Try to see, the source are not changing. But in case of exchange, you are actually exchanging both of them. So that is a different purpose. But in case of add and sub, you can see we have C8 and 6. Then after the, if we do subtraction, that is 2, and this 6 will be same. So basically this is AX is basically equal to AX minus BX. Is it clear?
Yes,
So
sir.
what if something after adding something the memory is overflowed, like
Overflow means?
after adding like
So
suppose
you're asking
AX is
you're adding FFF with 0 1, isn't it? You're talking about that.
yes
Because
sir,
we
like
can maximum
something
number
like
we
this.
can store is FFFF.
Yes sir.
Are we saying about something like that?
Yes sir, something like this.
Okay. So the maximum number in a register can be FFFF. And if we add 1 or 2 with that, what will happen? Isn't it?
Yes sir, this was the
So
question.
okay, this problem we'll discuss that in the next lab. We have flags, isn't it? There will be carry flag, then the carry flag will be 1, there will be carry, and the total value will be 0. So we'll discuss about those things in the next class, inshallah.
So can I add a few things, Rubel?
Yes.
We faced a similar sort of scenario in the previous lab, if you remember, while finding 2's complement of when we added -5 and 5, then we faced a similar problem. Do you remember that?
Yes, sir.
The answer came in 17 bits, right?
Yes, sir.
Yes, sir.
So what did we do?
We ignored the first the
Exactly, we
leftmost bit.
ignored the leftmost bit. So that is exactly what happens. But as Robiul said, of course, there are some other indications which include flag. So you will be learning about flag in the next lab. I think in that case, you will get. But I mean, you already know what will happen if you exit, isn't it? You already know what will happen.
And sir, for the exchange, the should the two variables size same or can it differ?
Yes, that should be same. That should be same.
It has to be same. Huh? Okay, continue, Robiul.
Okay, so these are the rules. So I'm not going there. So here in the destination, you have general memory location. So these two can be destination and source can be these three. So if your source and there is a no if both the destination and source is the memory location. So that is an illegal thing. Okay, then increase and decrease. So you know that thing that just increase and decrease. It will increase. So ax will be ax plus 1. So the value will be saved in ax. So if we have fe, that will be ff, and then if we have fe, then fd in case of decrease. So that can be a register or a memory location. We can decrease and increase of a register. So you can write increase byte 1, the variable that we have declared earlier. Is it correct? Is it okay? Okay, there is another instruction called neg, neg, to just it can be used for the register and memory location. So it does this by replacing contents by its 2's complement. That means the same thing 005 we have seen the 2's complement is ffb. So if we just write neg ax, so ax will be having this value, and later on after doing the 2's complement, this will be the value in the ax. Is it okay? So that will refer to -5 if you go for signed interpretation. Yes. Have you got the point?
Yes, sir.
Okay. So here is the thing that someone was asking, that we cannot move a byte variable that has been declared as db. So you have declared that byte as db. You cannot move that one to ax. That is illegal. But if you write okay, move ah comma a, that will store 41h to h. And if you write ax comma a, that will do 00141 to ax, because this a have not defined previously. So it can be expressed in terms of 8 bits or it can be expressed in terms of 16 bits. So that does it actually accept both of them. So basically, in case of emulator, if we have any if you have written something wrong, there should be given one at least the, what should I say, there should be an error, obviously. So that is the thing. These are the basic instructions that we need to know. So we have learned about move, then exchange, add, sub, then increase, decrease, and neg. Total 7 instructions. Maybe that will be enough for today's lab and these instructions. But in the next lab, you will see that we'll have some more instructions coming into. Okay. So now the program structure. So the program is yes. Yes, you can see. Or you want to see now, or you are asking that whether we are able to see? Yes, you can see the machine code here. If I okay, here, okay, whenever we run the first code, I'll show you. And
You will
even in
see
the
it
last class I have shown you.
You will see it actually at the end of today's lab. But for seeing that code and understanding, you need to have these basic knowledges. That's what Robiul is trying to cover. Once all those pre-requirements are covered, then you will be able to see an entire code. At the end of today's lab, you will see.
Okay, now it is the important part, I should say. There can be so basically today's lab is basically a knowledge based. You know this thing and you need to implement those things. So it's no critical thing, but thing is that there are big contents, but those all of them are content knowledge based. So if we just throw once more or twice, then you will see those things are easy. Is it okay? So these are the structure that if you just classify this whole code into a few of the class structure, that what are these, then it will be easier. So just we'll see what are the mandatory things, or what are the things that we need to have for running a program. So here in the machine program, you can see it consists of codes, data, and stack. Okay, so they are structured as program segment, and program segment is translated into memory segment by the assembler. So those are the things that those will be saved to somewhere. So the thing that we are talking about, we will be talking about the memory model. Try to see here. We will try to see this thing, memory model, how to define stack. So what is that dot data and what is this dot code? We'll see this basically. So the memory model, you can see that dot model in the program. You have seen that dot model. You see that dot model is small. What does that small mean? So here you can see if we write small, that the assembler will get the idea. Okay, the code segment is enough to be saved in one segment and data to be in one segment. But in case of this, you can say whenever you write large, then code in more than one segment, data in more than one segment. And also you can see compact, code in one segment, data in more than one segment. So these are different things, but unless there is a lot of code and data, basically we use dot model is small. That is a directive. Okay, how many segments do I need to, after translating this, where should I save, where should I go save the code, where should I, how many segments should I save the data, that the assembler get the directive. So normally we use dot model is small. Is it clear? Is it clear? No, it is just giving the directive that, okay, I need one segment for the code and I need one segment for the data. If you write is small, and if you write medium, dot model medium, if you write, then the assembler, that is a directive. So that will, then the assembler will understand, okay, the code should be in more than one segment and data should be two segments. Then by that thing, actually the assembler will understand, or the microprocessor will understand, okay, I need two segments of this one. So overlapping things, okay, those things are whatever we have discussed. Okay, there can be overlapping or there can be so many things. But thing is that basically from the programmer side, we do not see all those things, whether those are overlapping or not. Is it clear? But obviously, if that is less than 64 kilobyte, obviously those segments are overlapping. Is it clear? Okay. So now dot data segment. Dot data is basically so it contains all the variables, and the variable and constant declaration are done in dot data, and basically the variable addresses are computed as the offset of the starting of this segment. That means whatever that's what I was saying, that whenever you are writing dot data and writing all this code, that message, then string, then character, uninitialized, initialized, all these things are in the data segment. So starting from the beginning of the first what should I say, the first variable, so it starts with that offset address of the beginning of this segment. After that it saved in the consecutive memory location. Clear? Is it clear? 88 or 134?
Yes, sir.
Okay. Yes. Yes, we'll discuss that one. We'll discuss that thing, why we need that carriage return line feed. Okay. Then there is the stack segment. Okay, dot stack, we need to write the size of the stack that we need. That basically this declaration of stack segment is used to set aside a storage for of the stack. It actually keeps a particular memory size for working with the stack. So if this is the general instruction, general thing, dot stack, and then after that you write the size. So 100H, we normally use 100H, and that is normal program. It is a reasonable size, most of the applications. But if you do not write anything after dot stack, that will basically save 1 kilobyte stack area for the total program. So normally we write dot stack 100H. So for performing any stack operation, so that can be by the assembler, or that can be by the microprocessor, or that can be by the programmer. We can use the stack. Let us say you are taking input from 1, 2, 3, 4, and then you want to show in the reverse direction. So you stack 1, 2, 3, 4, then you pop out from there 4, 3, 2, 1. So that can be an application. So there are many applications in case of procedure. Whenever you're calling a function, then the stack is needed. So for that reason, for stack operation, we keep a thing aside there. So in the code segment, you just normally write the code mainly. So there is a option, then after dot code you can write a name. But whenever there is your model is a small, dot model is small, there is no need to write a name. That is there is optional name segment. So you just write dot code, that will be enough. And the instructions are organized as procedures. Okay, I will explain this thing in the next slide. So if we put all the things together, so how our program should look like. So first of all, we need to define what is the model. Dot model is small. Select a memory model, then define the stack size. After that, we have the data, variable, and arrays declaration. This in this level, you declare the different variables and things. And also after that, we have dot code, and in dot code we have the main procedure. So try to understand here. This main is a name. At the first, we have seen that main procedure. This is the name of the procedure. So that is the main program. That is the main procedure. I'm saying procedure as a, you can say that is a code portion, which is the main portion of the than the other procedure. Like in a MATLAB, you need to call some function from a particular one for a script. So you can say this is a script from where you can call the other procedure. So that is the main procedure is here. So basically the idea is you need to start with a name, then procedure, and then name and end P will give the directive that okay, the main procedure has ended. And after that, the other procedure will be here, and at the end, the directive will be end and the name of the main procedure. So the last line of the program should be end directive followed by the name of the main program. That is the rule. The code segment, if I just repeat, the code segment, you will have a main procedure. You can have other procedure, like if you want to do square something, a value, you can call from here. So that is the procedure. So you can call from here, from there it will come here, and after doing all the thing, it will return to the next line. So these other procedures can be here. Is it okay? Are you getting me?
I mean,
so maybe in the next class we'll discuss in details of the procedures, how the procedure works.
One line like these other procedures are more of like your user defined functions in MATLAB or something like that, isn't it? Those are the things like similar. I mean, you understand what are user defined functions. So those are the things over here that we're talking about, other procedures in assembly language.
Is it clear?
Sir, the stack segment, the stack 100H. Sir, what is the use of this stack? Uh, like that the data segment is used for the declaration of variable, and it is referring to the data.
I have just mentioned that. I have already mentioned 2 or 3 examples here already. So you are just define the stack size. What should be the size of the stack? Normally, if we do not give this size, that will give 1 kilobyte. First of all, try to be clear here. And another thing that at the beginning we have heard about non-overlapping segments, those are 64 kilobyte. Try to see here in the program we only need 1 kilobyte or even less than that. So I'm just okay, I'm coming to that point a bit later. So you can see that the segments can be overlapped because we need only 1 kilobyte here. Okay, that is one thing. Another thing is that you are defining the stack segment, and from here what happens, that maybe you need to use this stack by yourself in the program. You want to keep something in the stack and that later one. Have you got my point? Even whenever you're using the procedure, maybe in the next class I'll show you from this particular line from where you are calling a procedure. So how the program will know that where to come back after finishing this total procedure. So that IP address of the next line from where you are calling, so that IP address is normally kept in the stack. So whenever it is coming back, does just pop out to the IP value. So these are the different things that you need to use that thing. But even in emulator, I do not know, you can just remove that, maybe the program will run. Is it okay?
Yes, sir.
That is the half of our class. It was already 60 to 70 minutes from the starting.
Yes, sir. It will be good, sir.
Okay, we can have a 3 to 4 minutes break, and after that, come.
Robiul,
Yeah.
I think after the break we can go for question answer session, and then we can finish the class.
Okay. Then we can move to the other topics, isn't it?
Other topic, yeah. So after the break, we will have a small question answer session that in the previous lab I said will be at the beginning, but however it will not be at the beginning. It will be at the middle, and I mean just after this break, and you will be asked questions randomly. You already know how I ask questions, and the questions will be based on whatever Robiul discussed up to now, that is up to slide 28, and your previous labs. So I hope you have a mental preparation for that. Okay, so see you after the break. আছে সবাই?
Yes, sir.
So let's start. Okay, today's questions will be very simple and precise, and
Yes,
please
sir.
do not waste time. The person whom I will ask, if you can answer, you simply answer. If you cannot answer, just say sorry sir, I don't know. As simple as it is.
Yes,
Okay,
sir.
okay, so let's start with ID. Okay, 144 Alvi.
Yes, sir.
144 Alvi. Okay, simple question for you. What is the size and purpose of operands register? What is the size and purpose of operands register? Can you?
I don't know, sir.
Okay, thank you. That's good. Okay, you can mute your microphone. Let's ask now ID 109 Riyadh.
Yes, sir. The operance registers is used for temporarily stores temporarily the values of some data.
Okay, and size?
In case of operations like exchange operations.
Yeah, got that part. And what is the size?
So it is 16 bits.
Okay, thank you. You can mute your microphone. Okay, let's ask next. ID 33 Tamanna. ID 33033. Present or absent? Okay, so I will assume that she is absent since she is not responding.
ও মেবি স্যার রবিউল স্যারের সাথে মেইল দিছিল ওর ফ্যামিলি
Oh, আচ্ছা আচ্ছা আচ্ছা, okay. Okay, now let's ask 134 Imon. Okay, Imon, tell me what is the significance of LSB and MSB? What is the use of LSB and MSB? What do we understand from LSB and MSB? Same question. From what? From LSB or MSB? For LSB, wait. Value is even or odd? Which one is odd? Which one is even? Okay. Okay, how can you understand the sign? 0 is positive, 1 is negative. What is the full form of LSB? Anyway, okay, thank you. Let's ask next one. 149, Mushur.
Yes, sir.
What is the largest negative number in 4-bit? Can you answer? Largest negative number in 4-bit.
Negative number.
What is the largest negative number in 4-bit?
So 1111. I don't know, sir. Sorry.
Okay, no problem. Let's go to ID 091. Kais,
Yes, sir.
can you answer?
Sorry, sir.
Okay, the question is open. Anyone who can answer, please tell me your ID.
Yes, sir.
ID, tell me the ID
Yes,
first.
92, sir.
Wait, I got 292 and 134. Wait, 134 key section আছে নাকি? Oh, আছে. Okay, 134 মাত্র answered. Okay, 92 please go. 92
Sir,
continue.
-8, sir.
Minus it. Can you just briefly explain how you got that?
Sir, for 4 bits, sir, we have 2 to the power 4. That means 16 up to 16. So if we divide it by for negative, we have to 0 to 8 and 0 to -8, sir.
Okay, 0 to 8 and 0. Okay, though the explanation is not so satisfying, but I'll take the answer. No problem. Okay, next.
Sir, won't it be -7?
No, it will be -8. You can check it. The actual explanation is what is the lowest number containing MSB1 in 8-bit? That is 1000, right? Right. So
Yes,
if
sir.
you convert
Yes.
1000 into, I mean, using 2's complement, you will end up getting 1111, and that is 8. So that will be -8. Okay.
Yes,
Well,
sir.
let me go fast. I'm running short of time. ID 16, Akib.
Yes, sir.
Why do we use NOP? NOP. This was from today's class. Why do we use NOP? That is no operation. Why do we use that?
Sir, can't remember.
Sir,
Huh?
I can answer.
Wait. Okay, so you cannot answer. All right. Next, let me go to ID 13. ID 13. ID 13 absent. Okay, so I will assume that ID 13 is absent. Okay, I have to ask one more. 103, Akash.
Yes, sir.
So why do you use NOP?
I don't know, sir.
All right, the question is now open. Anyone who can
Sir, I
answer,
can answer,
tell me
sir.
the
Yes,
ID.
sir.
Yes, sir.
ID
Yes,
got
sir.
So 115.
11. Dara. 1115. Anyone else other than 115?
Yes, sir. 48, sir.
138,
sir.
Wait. 138. 138 কি সেকশনের নাকি?
Yes, sir.
তুমি না B1 এ চলে গেছিলা?
স্যার ওটা তো শুধু স্যার একটা ওই যে ল্যাব আমার হচ্ছে প্রজেক্ট ছিল কম্পিউটারের ওই জন্য
আচ্ছা, তুমি আবার এই ল্যাবে ব্যাক। আচ্ছা, 138. ওকে, 138 আনসার।
স্যার এটা হচ্ছে স্যার আমরা যেন মানে ওই লাইনটা এক্সিকিউট না করে নেক্সট লাইনে চলে যাই, এর জন্য আমরা ওই কোন একটা লাইনের পরে এনওপি ইউজ করি।
মানে হ্যাঁ, সেটা তো নো অপারেটিভ, বাট সেটা আমি কেন ইউজ করি? আমি কেন এই লাইনটা এক্সিকিউট করলাম যদি কিছু নাই করি? মেইন কোশ্চেন তো সেখানেই।
মানে স্যার আমরা স্যার মানে ডিলে এক্সিকিউশন করার জন্য।
এক্স্যাক্টলি, ইন্টেনশনালি ডিলে করার জন্য। ওকে, আই উইল টেক দ্যাট আনসার। ওকে, নেক্সট আনসার, নেক্সট কোশ্চেন। আর কাকে জিজ্ঞেস করি নাই। ওকে, 145 তৌফিক। 145 তৌফিক, are you there? So I will consider that he is absent since he is not responding.
Sir.
Okay.
Sir, ID 13. Sir, আমার current চলে গিয়েছিল, so I couldn't respond.
Okay, so let me ask you another question. ID 13. Okay, so how many fields are there in a statement? In a statement,
fields.
Yeah, in a statement, how many fields are there? Can you answer?
So 4.
What are those 4?
So name, operand, and comment, and Sir,
Opcode.
I do
And
not
another is
know.
opcode. Okay. Operation or
Opcode.
opcode. Yeah, operation. Okay, so I'll take that. I think I'll pause up to
Okay,
here.
sir.
Acha, Robiul, please take over.
Okay, let's see. Our next topic is uh, basically how we can show an input output in the monitor, and how we take input from the keyboard, and how this thing will work. We'll see this part. So let's see how much we can move. Let's see input output instruction. So for this purpose, for input and output, for before going to there, I'm just asking you. I'm just giving you a scenario that let us say I'm taking this class, and during the class I have a phone call, and I need to respond that phone call. So that can be by a text message, or I just received that one. I say, okay, I'm in the class. So after that, I return to the class. So you can see, you can say that there is a type of interrupt in the class. So basically, I'm trying to give you an idea that how the interrupts works. Like I'm doing something, and something happens which triggered the interrupt. Like the phone rang, or the phone is ringing. So I need to take phone, or I need to text the message, or whatever. I need to do something. After that, I need to come back to the class. This is the class is going on. So in between, what I'm doing that is not supposed to do, but that has been triggered, and I need to do that thing. So I'm just explaining this thing so that you can understand a part of the interrupts. So basically from here, I can just give you an idea. The interrupts may be triggered by hardware and software. So I'm saying about that inside a program, you're writing a code. In the code, there we can use interrupts. So why we'll use that interrupt, I'll discuss that thing. So that can be either software or hardware, but the software interrupts can be basically, you have heard the term BIOS and DOS in the last class. So you have heard about BIOS routines that is saved in the ROM, and DOS routines that is the routine of the operating system. I have again said that routines are a set of programs or a program. Like if you want to take an input from the keyboard, there is a fixed code for that particular taking input. So that code is saved in the ROM. So whenever you call that one by an interrupt, that will be called, and that will invoke, that will I should say, what should I say, that will tell the keyboard to that will wait in the monitor. Okay, I mean, I need to take a input. Then whenever a key is pressed in the keyboard, that value will be taken. So all these procedure or all this thing has been saved in ROM, that means in BIOS. And also DOS have some routines, that means a set of programs. So BIOS routines are saved in the ROM and interact directly with the input output ports. So basic skin operations, moving the cursor or scrolling the skin. These are the operations that that are done by directly input output ports with the BIOS routines. And also we have DOS routine by which we do many things, printing a character or a string actually. So, but the thing is that this line is very important. Actually, this DOS routine use BIOS routines to perform different tasks with input output devices. So if I summarize here, we have just heard a few things. The program can have interrupts, and with the interrupts, we need to take input and give the output. And those programs are saved in BIOS routine and also DOS routine. But DOS routine and BIOS routine does different tasks. I have given few examples, but DOS routine basically use BIOS routine to interact with input output operations. Is it clear up to now? Is it clear? 15 or 88?
So could you
Anyone?
explain DOS routine again?
Yes, yes.
DOS.
Yes. I was saying that. Is it clear about the routines? What are the routines? BIOS routine and DOS routine.
Yes, sir.
So yes. So what I was saying, with the BIOS routine, it can directly what should I say, interact with input-output ports. You have also DOS routine. So DOS is nothing but your operating system. So they have some routines. So just one example, printing a character string or printing a character or a string. So whenever you are printing that one to the monitor, so basically actually that use the BIOS routine, basically it invokes the BIOS routine to perform that task. Is it okay now? So BIOS routine saved in the ROM, but DOS, it normally what it does, it actually comes from other location, and then it operates on the ROM and the RAM portion. So basically, DOS routine can do complex tasks, but that need helps of the BIOS routine. So that is the idea.
Yes, sir.
Okay. Now, to invoke that DOS and BIOS routine, we need this command int. You will see several times this int instruction. So it corresponds to interrupts. So if you are writing a code, let us say you're writing a code. So during the code, you need to show something to the monitor, or you need to take input from the keyboard. That the first program of our first program will be something like that. So that needs an interrupt to be done. So if you are trying to take input from the keyboard, that means the input-output ports. You need to take something or give output to somewhere. Then you need to use that interrupt in the code, so that it will invoke BIOS or DOS routine of that particular taking input and giving output, and that after performing that routine, it comes back to the main program. So that is the idea. So that int function, that instruction has the interrupt number. After we need to write a interrupt number. So in our program, or maybe in our whole course, we'll be using that int 21h. So why 21h? You can go to the appendix C of the reference book, Maru's book, and you can find that this is a DOS interrupt, and this has a large number of function using that 21h. You just go to the book and you see that there are different types of function that we can do with interrupt 21h. So I will explain how that works. That is a different thing, but try to get that there is a interrupt by which it invokes the DOS function, different DOS function, and which function will be invoked, that depends on something. So that depends on what? That depends on the age. So what I'm saying, like if you write int 21h in your code, whenever it will be executed, whenever the program will execute this line, this program will search for age value. What is inside that age? It will search for that particular value. So depending on that particular value, it will do the next task. It will know what I need to do or what it should do. It will come to know. So if I give you an idea, so whenever the program will execute in 21h, if it gets 1, that means 1h obviously, then it will understand that I need to take an input from a single key input. That means I need to take input from the keyboard. Whenever it will find 2 inside AH, then it will understand I need to show a output, a single character output in the monitor. And whenever it will find 9, understand that I need to show a string, a total sentence. Then whenever it will find 4ch in AH, then it will actually do what? At the end, you will see that it terminates the current process and transfer control to the invoice. That means it will transfer control to the DOS. Whenever you are running a program, so you are executing that program. After execution, if you just want to give the control to the DOS, in that case, you need to use this one. So in details, maybe we'll discuss whenever we'll go to the code, but try to remember that whenever the program will get in 21h, it will look for the value of AH. Is it clear? Is it clear that whenever it will run, it will look for the value of AH? Is it clear?
Yes, sir.
Yes.
No. Yes, this function number will be given by us. That means if you want to take, you just move ah, comma 1. Whenever you are moving 1 into ah, what happens? So in the next line, whenever these interrupts will come up, it will go for finding ah and it will find 1. That means you need to take an input from the keyboard. Is it okay? Okay. Now we'll see one by one. So our first program will be, we'll read a character and we'll display it at the beginning of the next line. So that is our first program. So for doing our first program, first thing we need to take an input. So how to take an input? So first thing we need to do what? We need to move 1 into age, so that whenever we give in 21h, it will look for the value of age, and that will give you the idea. Okay, I need to take it in. And after, whenever you press something in the keyboard, that can be a character key or a non-character key, like function keys like F1 to F10 or something like that. If so that this can be A, B, C, D or non-character key. So if those are character keys, those will though the corresponding ASCII value will be saved in AL, and if non-character value, 0 will be saved in AL. So what I am trying to say, if you want to take an input, you just move into age, then you write int 21h. This will invoke the DOS to take an input from the keyboard. It will actually search for the value of age, and when it finds 1, then it invoke that particular routine for taking the input. So whenever you press a key in the keyboard, that particular ASCII value will be saved in AL. That is the idea. Is it clear? So you just after writing this code, whatever I have just said, it has been written here. So character key, non-character key, F to 10, that will be 0, and all those things has been written here. So the idea is, whenever this line will be executed, there will be interrupt, and it will search for the value of age, and when it is 1, it will understand I need to go for the routine of taking input. So it will take input from the keyboard, and whatever the key will be pressed, that will be saved in AL, and that will be saved AL by that particular routine. Is it clear?
Yes,
Is
sir.
it clear to you? Okay. So that is the thing we have shown
How
here.
much time the processor will wait for the user to hit a key?
It will wait at least. I have not checked for how much time, but thing is that it will wait. It will wait until if you do not cut the program, I think.
Okay, sir.
So you can see that whenever we'll run the program, you can wait for a few moments, and that will just blinking. So is that whenever you are writing a code, it is better to whenever you are giving this to a user, so better he can also understand that thing. For that reason, so whatever it is saying, that we need to display a question mark, so that the person who is giving the input, he can understand, okay, I need to give a input. Otherwise it doesn't prompt that, okay, you need to give input. That will wait, but it is difficult to understand that whether that is waiting or not. So okay, just we'll show a so a program. You have seen that program, what we were talking about. So here this question mark will show this question mark. After that, we take the input, and in the next line we show the output. Okay. So the second thing is that we need to now take the input, give the output, a character, a single character to so the character can be a character or a control function. Okay, so we can divide this one as a display character and control character. Okay, I'm coming to the point control character, but for the time being, just remember we have a character. So if you want to display something, so what should we move to age? What should be the value of age? Anyone?
2.
2. Then you in 21 age. Then whenever this line will be executed, So it will search for age and it is 2. That means I need to show something. So from where should I show something? So that also has been defined. That is from it will go for DL. So what is inside DL? So if you want to print something, let us say if you want to print A, or you want to print a question. So whatever you want to print, you need to move that before that N21H, so that whenever it comes to N21H, it will go for searching AH. H will get 2. It will get 2, and it will okay. I need to print something. So then it will go for searching the value of DL. So whatever inside DL, that is the ASCII code that will saved 101. So that corresponding character will be shown in the display. And after that, whenever this will be executed, that means it will be shown in the monitor. After that particular ASCII value will be saved in AL. Is it clear?
The line was not clear.
Okay, whenever you will come to this line, this will search for the value of age. It will get 2, and after getting 2, whenever it will okay, I need to print something. So what to print, that is inside DL. So I need to move that particular character into DL. Whenever it will get that question mark into DL, so it will print that question mark in the screen, and after that the ASCII code of this question mark will be saved in AL. That is the total routine. Have you got a point?
Yes, sir. It will automatically save the output value
Automatically it
to
will save
AL.
the value to AL. Yes.
Okay, sir.
Okay. Okay. Now, and after displaying the character, the cursor will advance to the next position. Okay. So there, I was saying about some control keys. So these are the control like 07H. If you move 07H to DL, so that will beep. That will give a beep, and 08 will give backspace, 9 will give tab, and then I was saying about new line, going to the new line. So this is the screen, you are in this position. So you are in this position, you want to go to the next line. So how can we go to the next line? So that you need to print these two things, control variable. This actually moves the cursor position. So line feed basically goes to the next line, and carriage return comes to the start of the current line. That is, in a monitor, if you are writing something you are writing and you are here, sorry. So you are here, and from here you want to go to the next line first position. How to go there? Then you need to execute these two things. You need to print these two control key. That means first thing is the line feed. It will go to the next line, the same position in the next line. And carriage return, that will take the position to the starting of the that particular line. So either one will do. Like if you want to print in other ways, that it will come to the first and go to the next line. But print these two. Is it clear? Anyone?
Yes, sir.
88.
Yes, sir. Yes, sir.
Line feed and carriage return. That means you can go to the next line and come to the start of that line. That means you are going to the next line. That is the idea.
Yes.
Okay. So and also you can have the beep, backspace, tab. You can use all those things. Okay. So when do we need the backspace? We are taking an input, and after that you do not want to show that input. So you just use the backspace that will remove that particular input. So that is the one use. So you can use different things from here. So that is our we are going to the first program. So what I have said. So okay. So dot model stack. So this is the first line and this is your second part. So dot model dot stack dot code. In this program, we do not have. We want to take an input and want to display the output in the next line. So we do not have dot data because we do not have any variable. So the dot data has been omitted from here. So dot code main procedure and end main procedure. End main. That means end main is the last line should be end, and the name of the main procedure. And here you can see move age, comma 4ch 21h. So in emulator, if you don't give in one, that will work. But thing is that the practice is these two line. So whenever this line will be executed, so it will search for value of age, that is 4ch. And if you just go to the appendix, not only these four, there are maybe 20 or 25 different uh, actions that can be taken using interrupt 21h. You can find there. But what it actually at the end of the program, it will basically transfer the control to the operating system. After whenever it is executing the program, after that it transfers the control to the DOS. That is the idea of these two lines. So even if you do not write these two lines, that will work in emulator, no problem. So, but for your understanding, I'm just giving it here. Okay. Now, these two lines, I think it should work. Like emulator is not a that is just emulator 086. So basically, this transfers the control. You can actually check whether it works or not. Okay, we'll check that at the end. Okay, so how if we just subdivide our program, then that is a very good practice that you do part by part, not all do one part, run that part, and after that you go to the next part. So first of all, we need to display a question mark, then read a character. After that, we'll go to the next line. The cursor should be moved to the beginning of the next line. After that, we display that particular character that has been taken as input. Have you got this 4 steps?
Yes, sir.
Okay. Now our first program, we how to show the character. Let's move your 2 into age and whatever the value you want to move to DL. So these two lines you can exchange, no problem, because this particular line will search for age first. What is inside age? And after having the value of age, it will decide what will be on my next step. So whenever it will see that, okay, I need to, it will invoke that particular routine of DOS, and that will search for the character that I want to show in that in DL. So if you just swap these two, that will work also. And even okay, I'll show you another thing at the end of this program. So how to read a character? Then we have done this one. How to read a character?
By one.
Okay, we need to move age 1. Then we need to run this in 21h. This two line will read a character. And after that, I have said that particular character will be saved in AL. But in this case, you see, after running this program, also AL will have the value of ASCII value of this one. So after taking the input, what is our next step? We need to move the cursor to the beginning of the next line. That means we need another 3 into 2. That means one for printing 0AH, another for printing 0DH. So when we print those two, so this AL value will be updated. So we lose that that particular input value. So what we did, we just moved that AL into other register so that that will not be lost. Is it clear? Yes, I'm repeating. So whenever you want to do the carriage return and line feed, after each of these two, what happens? AL will be updated to 0DH. And after that, after running this one, AL will update it to 0AH. But if you give the input as 5, so that 5 will be erased after running these two line. So what we are doing, we are just saving that AL into BL so that that will be saved in other register, and even if the AL is updated, that particular value will not be lost. Have you got my point?
Sir, can't we do the carriers return and line feed before taking the input? Just after
So
printing the what?
actually, what you are doing, you are just giving a what should I say, a question mark. After that, whatever you are taking input, that will be displayed also. Whatever you are taking input, that will also be displayed. So our program constraint is that we'll show the output after after taking, let us say it is 5, and these 5 will be shown in the next line. So before taking input, so if what you are talking,
Yes, sir. I
something
get
like that,
it
you'll
now. I
come to
get
the
it.
next line and it will be shown here. Okay.
Yes, sir. I get it now.
Okay, so that is the idea. So our program demands something like that, and at last what we did, BL to be moved to DL. That particular BL that we have taken the input, we want to display that thing, and after that in 21H. So I'm saying again, if you just omit this line also, it will work, because this in 21H will search for AH value. So AH value are not changing. So this in 21, which will go for age, and the age value is 2, it will show something, and what to show, that is inside DL. So whatever we have taken, the ASCII value of 5 will be saved in AL, and that will be coming to BL, and that BL is moving to DL, and after that, that will be shown. Is it clear?
Yes, sir.
So let's see in the emulator. So our first program, so that particular program has been written here. So if we run this, okay, what I was saying, you can see for move age comma 0 to age, that is our first command, and we have 2 machine code. Someone was asking that how can we see the machine code, that is B402, that is the machine code of move age 0 to age. And I have said that this is particularly your CS and this is your IP, and this is the physical address where it has been saved. So if we run is yes, anyone? If you want to run a single step, what will happen? So this move age comma 02. So age will get the value 02, and then we have 3F. So our first character is the you can see this 3F is corresponding to the ASCII character of a question mark. So this question mark is 3F. That is the corresponding ASCII value. So you go to the next step, then you are getting DL is getting 3F. After that, you are calling that 21H. So you just call 21H, then this screen will come up, and you can see after executing AL will get the value. So you can see AL value has been updated to 3F. That is the ASCII code of the of what? That is the ASCII code of question mark. Yes. Is it clear? Then you are going to the next line. Move age comma 02, 01. So after by this you can see that these are the steps. Now it is waiting for the input. So it will wait for the input. If we keep it, and then it will wait for time. So we are giving the 5, and after that the next program we have written such that then you can see at the end the program has returned the control to the operating system. Okay, so that is the idea of the whole program. Okay, let me do one thing. Let me delete this too. So emulator is halted. So try to see the message beforehand. In the previous case, I've seen the message that the emulator has transferred the control to the operating system. Now it is giving the emulator has halted. Is it okay?
Ruby, let me add one line over here. I mean, these two line is similar to your in C programming. Remember, you had an instruction at the end that is return 0. Do you remember?
Yes, sir.
Your C program would also run without return 0, right?
Yes, sir.
But that was a good practice, and that returns control, or it indicates a programmer that your code has been executed successfully, right?
Yes, sir.
So that exact thing is coming over here in assembly language. Instead of return 0, you are writing these 2 lines. Is it okay? Okay, Robiul.
Yes, yes. So that is our first program. So you just first I will ask you to do this thing by yourself. Try to see how things are changing. Even you can see the flags in the next class. We'll see the corresponding flags, how those are changing, and maybe in the next class. But you can see the changes in AX, BX, CX, DX, all these things, and you can see the change in IP and how these things are working. So that is our first program basically.
Sir, the 4CH in the 30, line number 30.
Yes.
Sir, what does this instruction do in the BIOS function? Like
Okay, I
for,
have said that in 21 is a DOS
oh, sorry,
environment.
sir, DOS.
Yes. So basically what it does, it transferred the control to the DOS. Okay. So whenever you are executing this program, so your microprocessor is running this program, isn't it?
Yes,
So
sir.
your microprocessor is at this program. So whenever after completing, this program has returned the control to the operating system. That is the thing it is doing.
Yes, sir.
Yes.
এখানে আমি একটু অ্যাড করি, হ্যাঁ। So the question you actually asked, that what is it actually doing? Okay, to answer this it gets a little bit complicated. Try to understand what this int 21h is doing. It is basically handling your input and output operations, right? Whenever you are trying to take an input or whenever you are trying to give an output, that is when you are calling this int 21h. Do you get up to this? I mean, up to
Yes,
this is
sir.
very clear, isn't it?
Yes, sir.
So the problem that happened is that whenever your various companies or even Intel started designing the microprocessor, I mean, as time passed, you do understand that whenever you connect an input port, or whenever I mean input device, or whenever you connect an output device, it has to be connected to some port of the microprocessor, right? It has
Yes,
to be
sir.
connected.
Yes, sir.
Now, every time in certain designs, they started changing the ports according to their own conveniences. Like, say, in the first generation, the port was, say, number 5 port. Saying in the second generation, the port became number 6, number 7, something like that. I mean, with each design, the ports started changing. So, what happens is when a coder starts coding, if he wants to take input, he needs to specify from which particular port he wants to take the input. Again, for displaying the output, he needs to specify which particular port he's trying to access to display the output. So see, in each time your microprocessor ports changed. So what happened is that every time if a programmer wants to program, he needs to again search, okay, which port do I need to use, which one do I need to use. Every time he needs to see that, and it is very problematic, isn't it?
Yes, sir.
So whenever they designed the microprocessor, they made some built-in routines. Those routines automatically, I mean, call those specific ports. I mean, the manufacturer, they themselves made those specific routines and they saved it. So all the programmer needs to do is invoke int 21h. That automatically knows which particular routine to call, and that routine contains your specific port numbers and all the details, so that the programmer does not need to bother with all these silly scenarios or silly things. Do you get the point?
Yes, sir.
So now if you ask that, I mean, how does this actually return the function? So see, that is, I mean, to answer this, it will take a lot of explanations, which as a programmer, we don't need to know. We just need to know that our job over here is done. So let us just transfer the uh, command to something else. Is it okay?
Yes, sir.
Okay, Robiul.
Okay. We have seen our first program, and we have come to know three things about the int21 each, about 1, 2, and 4ch. So there's another thing for displaying the string. So you can see that particular thing, that is we are moving 9 to 8. So after that, if we go for int, then it will show the particular string. So I'm just asking to you, that are you okay that we're continuing, or should we give a break today and maybe from the next class we can start from here? What do you think?
Sir, we can practice this much until today and continue in the next class.
Okay. Any other opinion from any other one?
So
Yes, sir. That
go
will
Yes,
to
be
the
okay.
next class.
I'm just asking that, have you understood whatever we have explained up to this 30 slide number 30? Oh, sorry. Have I stopped sharing? No.
No, sir.
Okay. So have you understood up to 30 slide number 35?
Yes, sir.
Yes, sir.
So I'm just asking how, if it is loaded, like if you are overloaded, then I'll not continue. That is the idea. Maybe we can continue for the next class.
Sir, it will be better if we continue from the next class.
Uh-huh.
So it will be better if we continue from the next class. Until now, we should practice in this week.
Yes, sir. Yes, sir. Please continue from the next lab.
Okay. Arif there.
হ্যাঁ বল
কি করব? বল।
That is fine if you say that we can continue from the next class, but our main motive is to make sure you learn something, but your class performance does not reflect that. The questions I asked were not at all complicated. If you're just attentive, you can answer those. So far I see that most of you could not answer. Maybe a few of you are answering. So it's a request, try to learn something. Okay, we are trying our best to give you something, but if you do not, I mean, at the end of the day, it is all up to you. If you do not want to learn, no one can make you learn. So try to give a few minutes, just half an hour. I think that should be more than enough. If you just give, you'll understand all these things. See, we have prepared, I mean, each teacher is preparing this PowerPoint presentation. You don't know how much work or time we have to give to make these presentations. We could have simply just followed the book. We could have simply showed you the PDF and continued, but we are not doing that. So since we are giving some effort, at least try to give some effort back so that you learn something. It is all for your own good, okay?
Yes, sir.
At the end of the day, we will not gain anything. It will be you who will gain something if you want. Otherwise, it is up to you.
And another thing is that obviously this assembly language will be needed in your assembly language is needed in whenever you will do the microcontroller in the next semester, and you will see that you will have on theory based on this assembly code, and there is some other there is obviously the theory related thing of 8051. And also this assembly will be needed in this, you can say, in whole 1 year time span. So this is the first class. So obviously I will request you to, this is the first class of assembly code. So just introduction. So try to get the things so that things will be easier in this semester and the next semester. Is it okay? Okay, in practical scenario, okay, that actually that is a question. So whenever you are doing, you are learning something, so whoever wants to make a career to a okay, I want to do things with microprocessor. So now you're learning how the microprocessor is working with assembly code. So that is your beginning. I have said in 8086, whenever at the first class I have said, now you are using i7 and with the latest generation, or maybe 8th or 7th generation. So that is 40 or 35 or 40 years back. We have an assembly language, all these things. So you're learning the ABCD. So if you want to move forward in this direction, that is a different thing. Have you got the point? Even if you say about the Arduino, that Arduino that you are doing for different robotics and all those things, that is a microcontroller. That is a particular code, but that code doesn't mean that code is not related to assembly code. So thing is that it actually, how should I say, when you are finding a track, you need to you are learning the initial things of those things. That is the main issue, and you know how to interact with the microprocessor. You know this thing. Whenever you are, if your practical life or your career orientation is this one, then there is a whatever we're learning in the undergraduate, all those things are not needed in the practical life. If you go to a power station to do your job in your power generation company, so they do not need all these things. They don't need all these things means what I say, maybe a different thing is needed there, things related to power system. Again, there are things that needs coding and all those things. If you are on that, obviously you need something related to this thing. So it is actually not I cannot say particularly where actually you will need this thing. That is the thing. Basically, that depends on what you're choosing. Have you got my point? Okay, thank you. So before leaving, maybe I will take attendance. Okay, Niloy is not here. Okay, 16 batch 35.
Yes, sir.
Okay, sir.
স্যার
Yes, yes.
স্যার লাস্ট ল্যাবটাতে স্যার আমি থাকতে পারিনি স্যার, আমি